So we went into mirrors, right? We talked about concave and convex. And we know that concave is a type of, any mirrors, concave is a type of converging mirror, and convex is a type of diverging mirror. And you had, with respect to the mirrors, you have to know how to draw the ray diagram and also the equation. Participants, I need to okay. You had ray diagrams and equations. So the ray diagram for both convex and concave, the technique is the same. For ray diagrams, you had two rays that you needed to remember how to draw. The first one was parallel to principal axis. And the second one was into the curvature, into parallel to principal axis, and then hits a boundary, gets reflected into the focal point. Gets reflected into focal point, into F. Okay, so that is your first one. So, and then your second one is into the curvature, into the radius of curvature, into C, back onto itself. And again, if your lines do not meet, extrapolate the line until it intersects. Where your line intersects, so your image is formed between intersection and principal axis. Okay, sorry for the bad handwriting. That is the point. Okay, and then we discovered that we have a bunch of equations for mirror. You want to see me? In myself. Okay. For equations of mirror, we only had two, I think. We only have two. One is 1 over u plus 1 over v equals to 1 over f. And remember, if it is virtual, it should be negative. If it is real, it should be positive. For concave, it's a positive f. For convex, it's a negative f. You don't have to memorize whether it's concave or convex, but you need to know if it's a diverging mirror, it's a positive f. If it's a converging mirror, it's a positive f. And if it's a diverging mirror, it's a negative f. Okay, real, virtual, and then another equation is magnification, which was height of image over the height of the object equals to minus v over u. And again, v is the distance of the image to the mirror, and u is the distance of the object to the mirror. Okay, so that was on mirrors. And then did we go into lens yet? Okay, so we summarized what happened for a concave mirror and a convex. For a diverging mirror at any distance, it is always virtual, upright, and diminished. Sama macam 711. How do you spell it? 711 punya mirror tu. Okay. And another thing to remember is this guy. U at F, no image. Okay. Oh, this is the magnification part. M positive is upright, M negative is inverted. Okay, bigger than 1, magnified. Okay, we have done this. And we also talked about lens. So we had two types of lens for this syllabus. We have a lot more, but we are only learning about converging and diverging. So we have the, the convex lens and the concave. The convex lens is thickest in the middle, okay, and the concave is thickest at the edge. Okay, something like a characteristic that maybe they can ask. Okay, so parallel rays, because light can travel through lens, your focal point depends on where your incident light is. But in general, they have the focal point on both sides. Because why? Incident light can come from the right, incident light can also come from the left. So it depends on where your incident light is to determine which one is your front, which one is your back, which one is your real, and which one is your virtual. Okay. Okay, bye. And then we talked about the Lens-Maker equation. Lens-Maker's equation. Lens-Maker's equation. Okay, and yang ni saya cover hujung waktu, so I'm going to repeat it again. This guy is the focal length. This guy is the index of refraction. This is R1, the radius of curvature, R2, radius of curvature. Which one is R1, which one is R2? If my incident light starts from the left, this part will be my R1. If my incident light is from the right, my right side is gonna be R1. Okay, nanti kita tengok contoh kalau ada. Sekejap. Do we have any? Okay, I think it's in your book, in your module book. Page, excuse me. Page 142. Okay, so it looks like this. Alah, tak nampak. Alah, tak nampak. Okay, tengok sendiri. So it's a biconvex, concave, plano-convex. So kat sini dia label R1, R2, which one is R1 and R2 without indicating the incident light. But you should indicate the incident light. Mana? So, saya rasa ada. Outer curve. Inner curve tu tak ada. Oh, saya kasih contoh, saya lukis sendiri. Okay, never mind. Okay, I'm gonna draw it then. Rasa macam ada last time rupanya lukis sendiri. Okay, so we have the biconvex. Wow. Okay, so this guy becomes R1 if my incident light comes from this side. Okay, just repeating it again slightly. So this guy becomes R2. Remember, if your lens curves outwards, it's a positive. If it curves inwards, it's a negative R. Okay. So sini dia cerita object location, object image location, lens radius, and the focal length. If your object location is at the front, front is where the incident light is. I got this table from your textbook. Okay, siapa yang tak tahu nak buka textbook lagi dah hujung semester ni, insaflah tanyalah kawan-kawan Jangan tanya saya lepuk je nanti. So in front is where your incident light comes from. Incident light comes from, and the back is the back lah, the back of the lens. And then if your object location is P, positive in front, negative, and the image location, we always expect our light to travel through the lens. So we expect our image to form at the back of the lens. So that is why your back is positive and the front guy becomes negative. So front part is virtual, back part is real. Okay, jangan nak buang. And then you have the lens radius, negative in front. Negative. Focal length F. Kejap, yang ni abaikan dulu. Saya akan confirmkan balik. I forgot this part. Focal length F, converging for converging lens is positive, diverging lens is negative. Okay? So sama dengan mirrors, you don't have to memorize much. Only the Lens-Maker's equation is a little bit different. Okay? Yang lain semua sama equation dia. Have we done this one yet? Not yet. Let's do it. Okay, stop sharing. Okay. I'll open recent. Stop sharing my new screen. Microsoft Word. Open recent exercises. Okay. So a converging, oh belum share lagi. Stop share. Sharing. Okay. Okay. A converging lens with, sekejap, I'm muted. Okay lah. Tak dengar semua orang. Sorry, ada questions tak? I forgot again. I muted you guys. Any questions? Yeah, is everyone okay? I'm going to continue. Converging lens with two curved surfaces has a front surface with a radius curvature of 10 centimeter. So tahu, so it's a positive 10 centimeter and has a back surface has a radius curvature of 20. Back has 20 centimeter. Made from a material with index refraction of 2.5. Okay, so that's the index of refraction. What is the focal length of the lens? Okay, so using your lens maker's equation, it's 1 over f n minus 1. Lebih tebal sangat ni. Sekejap n minus 1 and 1 over r1 plus 1 over r2. Here they did not indicate which side is gets the incident light, so you can just assume either one. So 2.5 minus 1, 1 over 10 centimeter. I told you if you make everyone centimeter, then you will get your answer as centimeter. Okay, so you don't have to convert because n is unitless, so you don't have to worry about that. Okay, so use your calculator. I don't know what the answer is. Harap ni samalah dengan jawapan tu. 2.5 minus 1 times with 1 over 10 plus 1 over 20. Okay, then 1 over that answer gives me 4.44. Okay, great. Same answer. So using your Landmaker's equation, that is your answer. Next one, senang je kan, just using the equation. So chapter 11 is just knowing how to use the equation, okay? Should be full marks there. A contact lens is made out of plastic with index refraction of 1.5. Okay, 1.5. The lens has an outer radius of curvature, outer radius, that is 2, inner. So here the word is inner radius. So it should go inside lah, 2.5 centimeter. Even though they give you a positive value, but they said inner radius. So inner di ke dalam, it's negative. Positive. So curving outwards, positive, curving inwards is a negative. Okay, using your Landmaker's equation, n minus 1, write your equation first. You should get marks for this, 1 over r1 plus 1 over r2. N is 2.5 minus 1. Then we had the r as 2 centimeter plus minus 2.5. Okay, so use a calculator. Get the answer. Let me check if it's the right answer. 1 over 2 plus 1 over 2.5. 1 over that is 1.1. Silap. It's a negative. 1 over 2 plus 1 minus 1 over 2.5 times with 1.5. Answer. Oh, saya tak dapat ni. Semalam saya dapat. Sekejap, check balik.
Doctor, isn't the index of refraction is 1.5?
Oh, sorry. Betul. That is why. Thank you. 2.5 ni apa? Oh, this guy. Thanks. 1.5. So, dapat tak jawapan? Ke kau nak kira? 0.5. 1 over 2 minus 1 over 2.5 times 0.5, 1 over that. Okay, dapat 20 centimeter. Thank you. Okay, so that is your second question. Third one. A plano convex lens N is equal to 1.5. What must be the radius of curvature? Sorry, it's flat on one side. Remember, if it's flat, your R is infinity. Did I tell you this? I don't remember if I did. Okay, so flat side, R equals to infinity. Curve side, positive. Inner curve, inner curve macam tu lah. Inner curve, this is infinity. Okay, so this guy is negative R. So R is flat on one side. What must be the radius of curvature of the curved side? R2 is unknown. To produce a converging lens. So converging lens, positive F of focal length 20 centimeter. Okay. It's positive 20 centimeter. So I have the N, I have the F, I have R1, I don't have the other R. I don't have the other R. So 1 over F. Then let me make this equation again. N minus 1. 1 over R1 cancels out to 0. 1 over infinity is 0 if you don't know yet. I'm going to tell you. Okay, jangan buat salah kat situ. So 1.5 minus 1. 1 over infinity, 1 over R2. Excuse me. 1 over 20. Okay, so now you can solve for R2. Just simple math, which sometimes kita pun tersilap. So that is why you have to double check your answer. 1.5 minus 1 times with times with 20 gets me 10. Okay, so your radius of curvature is positive 10 centimeter, which means that it's curving outwards. Curve size positive. Okay. Yang ni kita baca belum kejap. Let me check back the slides. Are we getting into the... Okay, not yet. Okay, untuk sabar dulu. Stop sharing that one. Share this one. Okay, I hope everyone is still with me. Jangan tertidur, please. Kita punya class 1 hour je. Okay, so three rays are drawn for the length. But again, I always tell you, you only need to know two rays. Okay, the first ray is drawn parallel to the principal axis and then passes through or appears from one of the focal lengths. So again, this depends on where your incident light is. The second ray is drawn through the center. So this is the part that's different. The first ray is the same, draw a parallel line, hits the boundary, goes into the focal length. They're refracted, so it goes into the focal length. Kalau converging, it goes to the back. If it's a diverging length, it goes to the place where the incident light is. That is where your focal point is. Nanti kita tengok. The second ray is drawn through the center. This is different compared to mirrors. Mirrors, the second ray is drawn into the radius of curvature. So take note of that. That part is different for lens. The image position is located on the cross section of the lines. Okay, sama. Intersection gives you the image. Okay, so this one is converging. How do I know if it's converging? Because the focal point is at the back of the lens. Remember, something that we expect is our converging. So I want my light to travel from here. I expect the light to be refracted because the lens lets us refract light. It does not reflect, it refracts. So I would expect my light to go on the other side. So that is where the real is. That is where my focal point for a converging lens is. Okay, sama juga macam mirror saya cerita hari tu. I expect my light to be reflected on the same side. So that is where my real is. Okay, that is very important to know how to determine which one is real, which one is virtual. You don't have to memorize. You can just make sense of it. Okay, so draw your principal axis, place the lens, mark the focal point. Okay, so converging lens, you will get to know what is the length semua from the question. Place the object. The first ray is drawn parallel to the principal axis. This is your object. Draw your draw your first light, first ray, parallel to the principal axis. Okay, parallel, this is your principal axis, so it's parallel. And then it is refracted. It's not reflected, it's refracted into the lens and into the focal point. So that's your first ray. R1, done. Second one, R2, into the center of the lens. So it will always touch the center of the mirror. If it's not touching, draw it again. Okay, that is where your intersection is. Your principal axis is here, so this is where your image forms. Okay, so easy, sama je macam mirror except the second ray. This is a diverging lens, and I know this because this is my incident light. This is my focal point. It's somewhere that I don't expect it to be because I want my light to be refracted at the back. But instead, I'm going to be drawing the line with respect to the front focal point. Okay, so parallel light that is, light ray that is parallel to the principal axis hits a boundary, gets refracted, but is diverged. How do I know which way it is diverging? Extrapolate my line into the focal point and then extend my line over here. Okay, so actually I need to start with the extrapolation. So parallel line goes into the focal point, extend my line. That is where my light is refracted. Okay, second one goes into the center, pretty easy. So where do I intersect is that principal axis is here. That is where my image is formed. Okay, remember the intersection is where you start your light. If you start your light at the top of the image, the intersection will give you the top of the image. Okay. Okay, here if it shows you an example of a converging lens where the object distance is greater than the focal length. So your focal length is here. Remember that you have your focal length on both sides. So if you place your object over here, walaupun this is not supposed to be your center focal length. Okay, so you could do that. So this is your third ray actually, which is confusing in my opinion, but you can do it. Okay, so you have three rays over here. Remember, lens has two focal points. If you decide to place your object at a greater distance than the focal length, you can draw three rays. Kalau tak, boleh juga rasanya, tapi confusing lah. But never mind, let's do it. Object distance greater than focal length. This is your first ray, parallel to the principal axis. This is my first one. And then goes into my focal point. And then your second one, this is your second ray, goes into the center. This is where you intersect. Dah dapat jawapan dah sebenarnya. But if you like, the third ray goes into the focal point. And then, is this necessary? If you don't have this intersection, kejap, tengok balik explanation tadi. Third ray is drawn from the focal point and emerges from the lens parallel to the principal axis. Okay, so that is the instruction. Okay, so dia cakap goes into the focal point and then parallel to the principal axis. In my opinion, you don't need this, but if you can if you want. So this is where you intersect. Principal axis is here, image. Okay, boleh juga, but I only use two selalunya. Okay, so next one, image distance is less than the focal point. Sorry, object distance is less than the focal point. Where is my object? It's here. This is my object. Okay, this is my focal point. Okay, so let's draw the rays. The first one, parallel to the principal axis, goes into my focal point. This is a converging lens. So the focal point is on the other side of the lens. Second one goes into the center. Here, they keep on increasing. So I know that they won't intersect there. So what do? I extrapolate my line so that it intersects. So this is where it intersects, principal axis. That is my object. Image. Salah tertukar. Okay, so you only needed two lines. What if we wanted to do the third line? Oh, macam tu okay lah kot. So you start with the top. Did it help? Oh, it did not help. I needed to extend this. Never mind the third ray. Buang. Okay, so you got the answer using 2 rays. So I need the third one. Okay, next one. Image is virtual and upright. This is for when your object is greater than the focal length. This is for a diverging lens. Okay, so diverging lens, if your incident light is here or your object is that side, your focal length should be on the same side. This is very, very, very important to take note of. Focal point is at the same side as the incident light and the object. Okay, so let's draw your parallel line, goes into the focal point, extend. Silap, extend kat belakang ni. Extrapolate, straight line. Okay, that's your first ray. Should be like this. Diverge. Okay, patutnya is a dotted line, sepatutnya. Dotted line because we know that light is supposed to be refracted. Okay, so next one is second one into the center. Where does it intersect? It intersects here. Principal axis is here. That is your image. Okay, so that's pretty easy. Again, for a diverging lens, the image is always virtual and upright. And diminished, is that part of it? Ke yang ni untuk mirror je? Sekejap. You summarize tak? Yep, it's diminished as well. Okay, sama condition macam diverging mirror. Virtual, upright, and diminished at any distance. Okay, sama juga kat sini, converging lens at u equals to f, no image is formed. Similar to your mirror as well. Oops. And the equation for lens is the same as your mirror. It's 1 over u plus 1 over v equals to 1 over f. For a converging lens, it's a positive f. For a diverging lens, it's a negative f. If it's a real u or v, positive. If it's virtual, u or v, negative. So you need to know which part is real, which part is virtual. Okay, let's talk about the positive real and negative virtual now. Your image is formed here, which is somewhere that you don't expect it to form, right? I think I mentioned this 5 times already. Your light passes through, it wants to be refracted. So this is where your real is. Because why? We expect the light to go on the other side. So this guy becomes the virtual side. This guy becomes negative. This guy becomes positive. Okay. And this one sama juga. Real, virtual. Okay. It's the same. Positive if it is this on the opposite side of the object. Oh, there's another way to know this. This is the slides tips. Positive if it is on this opposite side of the object. Negative if it is on the same side as the object. Okay, that makes sense. That makes sense as well. Okay, if your u or v is on the same side, if your v is on the same side as u or your object, it's a positive, of course. If your image is on the opposite side as the object, it's a positive. Okay, God, so many terms. Okay, so magnification can also be calculated for lens equation. For lens, m equals to h image over h object. Sama, exactly the same. So you don't have to memorize much here. This equation can be used for both converging and diverging mirrors. So combination of thin lens, we won't cover this. It's not going to be on the exam. Okay, I think we are done. Let's do the exercises if we have time. We have 15 minutes. Let's do it quickly. Stop sharing.
Dr. Nat,
Yep.
regarding the formation of image by converging lenses, it's the same with converging mirrors, right? Like at the distance for converging lens and converging mirrors, they form the same kind of image, right?
Form the same kind of image. I'm not sure. I didn't compare. Is it? Is it the same? Saya tak pernah hafal pun. So I just draw it. Is it the same? I don't know. Is it the same, Belle? Do you know? Is that a summary kat sini?
Hold on, doctor. I'm making the comparison.
If u is greater than 2f, the object is the image is real, inverted, and smaller. Is that the same for the lens? Mana dah? U is greater than. For lens, it's if it's greater than the focal point. If it's for mirror, it's greater than the radius of curvature. It's not the same. Line bell is different. Ada summary dia. Summary dia dekat 143 and 138. 138 for mirror, 143 for lens. Don't think it's the same. Okay. Sebab mirror dia ada radius of curvature. For lens, we only have with respect to f.
Thank you, doctor.
Okay, let's do this one. An object is placed 30 centimeter from a lens. So, kenapa object bulat pula? So, object 30 centimeter from lens. So, okay, so u is equal to 30 centimeter. And a virtual image is formed 15 centimeter from the lens. So 15, it did not say if it's positive or negative. So what is the focal length of the lens? So 1 over f, so 1 over u plus 1 over v. Virtual image, virtual, sorry. Virtual, it's a negative. Okay. Virtual, if it says it's a virtual, it's a negative. If it says it's a real, it's a positive. So 1 over 30 minus 1 over 15. So you get your answer as negative 1 over 15. So that is minus, 1 over 30 minus 1 over 15 will give me negative 1 over 30. So that is f equals to, so this gives me f as negative 30 centimeters. So negative f means diverging lens. Okay, so that was easy, just using 1 over u and 1 over v. Next one. Okay, a thin lens has a focal length of 25. So f is 25 centimeter. Locate the image when the object is placed. So you have two scenarios. U1 is 26 centimeter and then 24 centimeter. So U number 2, 24 centimeter. Describe the image in each case. So we can draw it or we can be more accurate and use the equation. So let's use the equation. So for the first one, 1 over f equals to 1 over u plus 1 over v. So 1 over u, that is 26 centimeter, will give you an image of, so v equals to 1 over 25 minus 1 over 26. That gives me 650, positive. Okay, So positive V, what does that mean? It means that it is real. Okay, so that's your first information. 650 centimeter and it is real. What is 650 centimeter? It's the distance, it's not the height. All right, so now we have U and V. We can calculate for its magnification. So magnification is, it's H image. It's negative V over U or H image over H object, but we don't have this, so don't use it. So negative 650 centimeter over U1 is positive 26 centimeter. Because they are the same unit, both are centimeter, I can cancel them out. If let's say you get this guy is in micrometer or in millimeter, you have to convert everything to meter. Make everyone standardized. Baru boleh cross out. So that is, the answer is negative. Answer is negative 25. Magnification is greater than 1, which means that it is magnified. Magnified, and the negative sign means that the image is inverted. Okay, betul tak jawapan tu? Real, yes. Inverted, magnified. Betul. Okay, so using your second equation, you got another 2 information. Okay, that is for A. And that for B, your U is 24 equals to 1 over U plus 1 over V. This is 1 over 25. Remember, everyone has to have the same units. If not, convert everything to meter. 1 over U, 24, then 1 over V. So V is, use your calculator, 1 over 25 minus 1 over 24. Okay, so that is negative 1 over 600. Tu tak? Sorry, that is negative 600 centimeter. What does negative mean? It means it is virtual. Okay. Next one, use your M equation. Negative V over U minus 6 minus 600 over U. U is 24. Centimeter cancelled out. This guy becomes positive 25. So the magnification is 25 times. It is greater by a factor of 25. The object is upright. Magnified. Okay, so that's how you use the equations. So this guy is minus 600 centimeter from the lens. It is virtual because it's negative. Upright because the magnification is positive. And magnified because it's greater than 1. Okay. Okay, so that is the end. Oh yay. Stop sharing. Lagi tak? Kejap. Let us check the slides if I missed out anything. But in terms of exercises, that is as much as I want to cover with you guys. Combination tak masuk. This guy tak masuk. 17, do it yourself. 17 ni kita dah buat. 18 kena buat sendiri. 18 is an application type of question. Please try it yourself. Please complete your web assignment as well. I think it's due on Saturday. So that is it from me for chapter 11. Next class, we will cover chapter 12. And that's your last chapter for this semester. Okay, so stop sharing. Okay, any questions for me before we end class? Don't forget to sign in at your Putra Blast. Okay. Okay, no questions? Okay, have a great rest of the day. Eat well, jaga SOP, take care of yourself. Bye.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor. Take care, Doctor.
You too.
Thank you, Doctor.
Bye-bye.
Thank you, Doctor.
Bye. You're
Thank you,
welcome.
Doctor. Thank you, Doctor.
Bye. You're welcome. Just still tanda kertas. I think by next week we will know the answer. I mean, we will know our marks. Bye bye. Kenapa semua orang tak nak keluar ni? Tidur lah tu. Ih.
Doktor.
Yep.
Uh,
Apa tak dengar ajak?
Kalau magnified,
Kalau magnified,
kalau magnified, dia macam mana? M2 lebih besar dari 1 ke
betul. M lagi besar dari 1. Kalau
kalau negatif?
Kalau negatif, maksudnya image awak tu inverted, dia terbalik. Tapi awak kena tengok value je. Sekejap, Yusof. Tahan sikit. Magnification tu, tengok value dia je. Kalau dia kurang dari 1, maksudnya image makin kecil. Tengok value je. Kalau greater than 1, objek makin besar. Image makin besar, sorry. Tapi positif dengan negatif tu bagi tahu
Kalau
awak
macam soalan
macam soalan tadi. Perasan tak kita buat?
walaupun dapat negatif 25 tapi tetap magnified.
Tetap magnified sebab nombor dia tu besar dari 1.
Oh. Arah je lah yang tadi negatif tu.
Sign tu untuk bagi tahu arah dia menegak.
Kedudukan dia.
Ah.
Atas bawah.
Betul?
Okay. Thank you, Rete.
Okay, welcome. Bye.